Today we're going to learn about the echinoderms. We've already covered some of the less sophisticated phyla or groups of animals. Remember, to be put into the same phyla or group, phylum, they have to have shared characteristics. We've talked about the porifera, which are the sponges, which are the simplest of all of these marine invertebrates that we're dealing with on the reef here. And we worked our way through the cnidarians, which are perhaps the most important. That would be the most important phylum, in that it includes the hard corals, soft corals, jellyfish, anemones, false corals, black corals, hydroids, all the things that can sting you. And we've worked up some other lesser phyla, and now we're at the echinoderms. And these punishing names always tell you about at least one of the characteristics that's shared by all of these different animals. In this phylum, we have 5 classes for the delineation of organisms. Echinoderm, derm skin, echino spines. So, but we're not talking about the sort of spines that you see on an urchin. We're talking more about these things called ossicles. Ossicles are little plates, and as is the case with an urchin, the skeleton is called the test, and all of these ossicles are fused together, making a solid structure. The other end of the spectrum on this last dive, we saw the Isostichiopus sea cucumber that has its ossicles widely separated, making it very soft, and that's why it can articulate. Yes, all of these organisms, some of them you're familiar with, some of them you're not, are part of the same phylum. We have got a starfish making up one of the classes, a brittle star, which we don't see normally during the day unless you're looking at sponges. They're more cryptic, and you see them come out at night. We've got a crinoid, which is very much like a brittle star. These are also called serpent stars because of the way that they move. Only they've taken this disc where you have mouth, anus, mouth, anus, mouth, anus. They've taken the disc and they flipped it over. And now the mouth is facing upwards, and how they make a living is they send out all these arms, and most of them around here have 10 arms. So we have multiples of 5. We'll get back to that in a second. These arms they've invented Velcro. They feel like Velcro, and they're opening up into the current, and when the current brings these small plankters, this bit of plankton through, they get snared on these arms, and then hairs push this food down to the mouth that's waiting, facing upwards. This class here, these are the echinoids, or the urchins, but not just regular urchins. Regular urchins have long spines and they live on top of the substrate. We also have got a whole gradient of other urchins. We've got a cake urchin that's starting to flatten out. The spines have become very small because these guys are exploiting a habitat just below the surface, and you can't have big spines if you're going to be doing that. And they have, along this gradient, you have a species now where the mouth has moved to the front, and the anus, it's not a good idea to defecate on yourself all the time, so the anus has migrated to the back. They actually have a front and back, whereas these guys don't have a front and back. They're radially symmetrical. And the advantage of being radially symmetrical is that you don't have to turn to face danger. You don't have to turn to gather food. You have all the same parts around each of these organisms. The sea cucumbers, yes, they are related to the starfish and these other organisms. They have taken this mouth anus and they've really stretched it out. The mouth is up here, the anus is back here, and they're going in a certain direction. Once you have this process, this cephalization, where you have bilateral symmetry and you're going in a certain direction, the sensory apparatus has migrated to the front of these organisms because it's a good idea to know if it's prosperous to go in a certain direction. If there's danger there, they know not to go in that direction. So you see the beginning of the change here with this symmetry. All of these guys have shared characteristics. We talked about the spiny skin, but there's also this pentamerism, a 5 pattern. And in the 5 pattern, it's very apparent, and there are some exceptions, but in their embryology, they all go through this pentamerism, this 5 pattern. And then we have multiples of 5 with these arms. We have 5 arms on the brittle stars. These urchins, they make a living by pushing down seagrass and eating algae. They have 5 teeth in their mouth here. They're made up of 10 pieces of pie, 5 of which have got tube feet and 5 which haven't. These sea cucumbers, the original sea cucumbers, did have neat rows of tube feet all the way around them. The one that we just saw down there, that soft one, had all the tube feet on the bottom here, and it helps with locomotion. These are actually very large tube feet to help push food. They push the sediment into their mouths and they digest away the organic part of that, the detritus. But getting back, they all, to one extent or another, have a 5 pattern. They also, talking about these tube feet, they also have a hydraulic system. A starfish, if you look at the dorsal surface of a starfish, you see this little bump. This is actually something called a madreporite. They suck water into that bump and they fill up this ring canal. And going off this ring canal into each one of these arms are 2 straight canals. And each one of these canals has a series of bulbs. There's a series of bulbs. Here's this canal, here's a bulb, here's a bulb, here's a bulb. These fill up with water. Each bulb has a corresponding tube foot. All right? Mussels cannot extend something unless there's a skeleton. There's no skeleton here, right? No internal skeleton. So they squeeze the bulb, and now the bulb goes into the tube foot and makes it extend. Then the tube foot grabs onto the substrate, the bottom, and it contracts. Mussels can contract, and as it contracts, the fluid goes back into the bulb. It's a pretty tight and economic system, and that is the reason why these starfish, which appear to be pretty feeble, are able to feed on something like a clam, which is really difficult. If you were at a picnic and it was your job to open up the clams, you understand how difficult it is. They have these large abductor muscles and they can keep their valves shut. But the starfish exerts a force, a pressure, and then there's hardly any expenditure of energy. Whereas the clam has to work hard to keep its valves shut. It's like us holding our hand up in the air. That's pretty easy. I'll see you back in 10 minutes.
Yeah.
And that's a major job now. So there's a tiny little opening after a period of time in the clamshell, and the starfish, which has 2 stomachs, one of them can leave as a filament and drop down inside this clam and digest it, fill it up with proteolytic enzymes and digest it, even while it's still pretty much closed. These serpent stars or brittle stars, they do not use their hydraulic system and their tube feet so much for locomotion. It's more of a gas exchange thing with them. Same thing with the crinoids. These starfish, these urchins, if you hold an urchin on your hand for a while and then turn your hand over, it'll be stuck with all the tube feet, and they use that to help move, and they also use their spines to help them move. The spines that are on the substrate down here are very small and they're easier to articulate. These have masterful water vascular systems. They use their large buccal tube feet to push food. They use these tube feet to help them move. They actually breathe through their anuses. They suck water in through their anuses and they fill up these respiratory tubules inside here. That's how they breathe. And then they exhaust the water out. And it lends itself to a very unusual relationship, a type of symbiosis with the fish that's called a pearl fish. It's mother of pearl in color. It's very silvery. The scientific name for one of them is Carapus carapus. You see where I'm going with this. And this particular sea urchin has 5 teeth, and not really teeth, but in the anus, just to make it more dramatic. And this fish has to find a place to hide. It goes out at night under the cover of darkness and it forages around. In the daytime, it has to find a place to hide, stay away from predators. And it has evolved together with this sea cucumber. When this sea cucumber opens up its anus to breathe, this fish backs into the sea cucumber. And there might be a number of them in there, and they're just hanging out. And people say, well, what does a sea cucumber get out of it? Because people don't understand the use of the word symbiosis. Symbiosis does not mean that there's a mutual benefit. There's a type of symbiosis called mutualism, where both partners are helping one another and they're both being aided by this partnership. But there's another end of the spectrum in symbiosis called parasitism. any two organisms, different species, that are intimately associated with one another is symbiosis. Okay, water vascular system, spiny skin, 5 pattern. They also have powers of regeneration. A brittle star, if a predator grabs the arm of a brittle star, snaps it off. It autotomizes its limb, and then a membrane comes down so there's no loss of fluid. And then weeks later, they grow a new limb. Instead of staying with the predator and trying to duke it out and maybe losing the battle, it's a defense mechanism to get away. Same thing with starfish. I remember being a commercial fisherman on the shellfish beds, and the starfish inundated the shellfish beds. And all these rocket scientists decided that they would collect all these starfish up on the decks of their boats and cut them up. If you cut up a starfish and you have a piece of the disc and an arm, you wind up with the asexual product called a comet star. Okay, there's the original arm. There's a new organism. They'll catch up. Powers of regeneration. Crinoid, something hits up against it with their Velcro arms, rips their arms off, they just grow new ones. And the same is this, it's the same with these urchins with their tube feet. They just grow new ones. These are the kings. Once again, these sea cucumbers that most people didn't know anything about are the stars of this phylum. What they will do, if we put one up here on the deck and waited a few minutes, you'd see it happen. The first thing that they do if a predator is bothering them, they're not very fast, right? The first thing they do is they send out these white spaghetti-like tubules, all right? And these have a great name. It sounds wonderful, like you might order it at a French restaurant. They're called organs of Cuvier. Oh, that sounds delicious. They're poisonous, and usually the predator cannot extricate himself or itself from that tangled mess. Sea cucumber just crawls away. Now, predator is smart, and the sea cucumber ejects these organs of Cuvier. And the predator goes, miss me, it's a matrix. And then it continues to bother the sea cucumber. What the sea cucumber does next is it eviscerates. It sends all of its guts through its anus. It does everything through its anus. So out come all these guts, and they're pink and they're attractive, I guess, for guts. And then the idea is, the selective value is that the predator will stay there and eat the gut, and then the sea cucumber will crawl away and grow a new gut. What? Isn't that amazing? Incredible stuff. So this is a group of animals, this phylum Echinoderms, the Echinodermata, that you can find on every one of these dives. Now you have a little bit of knowledge, and you have perhaps a little bit more respect for each one of these different groups, particularly the sea cucumber. There you go.